Good morning, one and all. This is Padmavati from Department of CSE. Today we are going to see two topics. One is sampling and quantization in image processing, and second one, after sampling and quantization, how the digital images can be represented. If, for example, if you take a continuous image, which is f of x comma y, which we want to convert into digital form, an image can be continuous with respect to x and y coordinates. That means we have only two coordinates, x and y, where f represents amplitude, x and y represents the pixel coordinates. We want to convert it into digital form. First, we need to sample the function in both coordinates as well as in amplitude. By digitizing the coordinate values is called as sampling. So sampling is nothing but whenever we are digitizing the coordinate value, and it is termed as sampling. And if you are digitizing the amplitude values, then it is called as quantization. For example, in this image, it is called as a continuous image. That means it lies along with the line segment A and B. The random variations are due to the image noise, which will be represented here. That is in this image. The location of each sample is given by a vertical tick mark in the bottom part of this image. That means here. The samples are shown in the white squares. These are all the sampling points. These points. See here you can see a circle mark, and here you can see the square marks. The set of these discrete locations give the sampled function. So this is nothing but the sampled value. This image can be sampled after this. So this is called as the sampling points. And here in the right side of this image, you can see a grayscales. That means it starts from black and it ends with white. And in between you are having the various shades of gray. For example, if this is 0 and this is 1. In black and white image, that means in black and white, that is binary image, you have only black and white. In grayscale image, you are having a various shades of gray. See, for example, this is also a grayscale image. See, here we are having white here, and here we are having black, and this is some dark gray, this is some light gray, this is very light gray. So this is nothing but the gray shades. So for example, if I take the value from 0 to 255, so these values lies from 1 to 254. If this is 0, this is 256 or 255, then this values lies in between. For example, this shade of gray, this is 0. So this shade starts from 1 to 10 or 1 to 20, like that. And this is 255 or 256, and this value starts below 255, 253, 252, 253, 252, 251, like that, these values. So these values are in between from 0 to 255. So these are all called as the various shades of gray. And here the vertical tick represents the specific value assigned to each of the 8 gray levels. The continuous gray levels are quantized simply by assigning one of the 8 discrete gray levels to each sample. That means each of the value has been given as one reference point, and that reference have been marked over in the image. And we have sampling in both coordinates, in both coordinate direction as well as in amplitude. But in practice, the sampling is determined by the sensor arrangement, which is used to generate various method of sampling for the image. When the image is generated by a single sensing element, which is combined with mechanical motion, this kind of sampling can be generated. See, this is my that is my continuous image. So I'm doing this sampling and quantization. See, this is nothing but the illumination source, and this is nothing but the imaging system, which is called as a sensor, and the image is kept on the grid. This is nothing but the grid. This rectangular array is nothing but the grid. So this image is exactly placed in the grid, and those are all the continuous points have been transferred into the digitized form. So this is nothing but the input image, and this is nothing but the discrete image, or it is nothing but the digital image, which is nothing but the digitized image. So next we'll move on to next topic, which is nothing but representation of digital image. As we all know, this is nothing but the array of pixels. So the pixel value starts from 0, 0, which is nothing but the origin, and it goes to n, n. And here, for example, this is 0, 0, this is 0, 1, this is 0, 2, this is 0, 3. So 0, 1, that means 0 represents row, 1 represents the column value. So let's see here. This is nothing but 3, 2, where 3 represents row value, 2 represents column value. Similarly, this point is 3, n minus 1, where 3 represents the row value and n minus 1 represents the column value. So this is nothing but the representation of image, and the same can be expressed in terms of matrix form. So in matrix form, we can just mention, instead of f of x comma y, here we are mentioning f of 0, 0, which is nothing but the pixel values. So there are various names of pixels that is called as picture elements or pels. Pels is nothing but the abbreviation of pixel elements. Picture elements, pels, image elements, and pixels. So what the pixel will do? Pixel will have the information about the image. Various information about your image can be stored in the form of pixels. And the arrays of pixel, that is a group of pixel, can be formed as an image. So in this topic, we have covered about how a normal image can be sampled and it is quantized, and this is nothing but a quantized digital image. Thank you.